everybody, Brian here. So excited to be working with you today, and we're going to be going over adding and subtracting fractions and mixed numbers. Let's get it. Hey everybody, welcome to adding and subtracting fractions and mixed numbers on the T6 math course with me, Brian. So let's jump right into it. All right, our goal for today is that we will be able to add and subtract two or more fractions, add and subtract mixed numbers and fractions, add and subtract mixed numbers, and add and subtract mixed numbers, fractions, and whole numbers. So there is a lot to get done in this lesson, so buckle up and let's continue. When we deal with proper fractions, that's fractions where the numerator is less than the denominator. So if our denominator, say, was 10 and our numerator was 7, 7/10 is a proper fraction because the numerator is less than the denominator, and all proper fractions are less than 1 whole. 2, we have a mixed number, so remember that contains a whole number and a fraction. So if we had 3 and 1/4, 3 is our whole number, and our fraction is the 1/4. Called a mixed number because it mixes whole numbers and fractions together. 3, improper fraction. These are fractions where the numerator is greater than the denominator. So for example, if we had 17/8, 17, the numerator is larger than 8 in the denominator, and these are all greater than 1 whole. So if you have an improper fraction, you have more than 1 whole. When we deal with adding and subtracting, we deal with the least common multiple. So that means the smallest skip counting number that two integers or whole numbers share. So quick example, if we were going to look at, say, 4 and 6, if we counted by 4s, 4, 8, 12, 16, 20, 6, 12, 18, 24, 30, and let's do one more for 4. Let's do 24. If we can see, they do share some multiples. So they both share 12, and 4 and 6 share 24. But we want the least common multiple. So what's the smallest multiple that they share? That's 12. So we use this for adding and subtracting, making sure that we find the LCM, least common multiple. Help us out. All right. Key point number 1, you can only add or subtract fractions with the same denominator. So in this case, we have 1/3 and 1/4. We cannot add them the way that they are, so we have to make some changes. Why is that? I want to show you real quick. So say we had this. We had a whole. Actually, we have 1 whole, and we have this here. If our fractions were not this, so if we had thirds here, and this one's in fourths, and I had 1/3 plus 1/4, these pieces aren't the same size. So it would be really hard to describe what we just found. So we can't have denominators not be the same, because then that means the size of the pieces are different, and we don't have a way to verbalize the amount that we now have. So we have to do something with those instead. So if the fraction or mixed numbers do not have the same denominator, we have to find the least common multiple of the denominators and make equivalent fractions. So our denominators are 3 and 4. So if we look, 3 and 4, we do multiples of each. 3, 6, 9, 12, 15. I like to do the first 5 of each to see if there is one. Otherwise, we have too many numbers there. I do see 12. That's my LCM is 12. So what I do is I take 1/3 and I take 1/4, and now I make their denominators out of 12. By using equivalent fractions, I use the same rules. I know that 3 times 4 is 12. So I have to also multiply my numerator by 4. That gives me 4/12. 4 times 3 is 12. So I have to multiply the numerator by 3 as well and get 3/12. Now I have the same denominator, so I can add them together. 3, when adding mixed numbers, you can add the whole numbers and fractions separately. This is only for addition. So for example, if I had 2 and 1/4, and I wanted to add 3 and 7/8, all I'm saying is step 1, you could do 2 plus 3 equals 5, and then focus on adding your fractions together. This is only for addition. Subtraction, you'll see something different may happen, and obviously when we get to multiplying and dividing, that's not going to work. So this is just a trick for addition so that we can put those numbers to the side. 4, when subtracting mixed numbers, create equivalent fractions first to determine if you have to borrow. So what I mean by that is if we have, say, 3 and 1/4 minus 1 and 3/8. We focus on the fractions first to give them the same denominator. So if I counted by 4s and I counted by 8s, 4, 8, 12, 16, 20. Honestly, at this point, you can stop at 8, 16 because you see 8 is the LCM. So that means I'm going to take 3 and I'm going to make 1/4 out of 8 minus, well, 3/8 is already out of 8ths. So I'm just going to keep that 3. 4 times 2 is 8. 1 times 2 is 2. So I have 3 and 2/8 minus 1 and 3/8. Now I know that I actually would have to borrow because I cannot do 2/8 minus 3/8. 5, when subtracting fractions or mixed numbers from a whole, you can use the counting up strategy. So I'll show you what that looks like. Say we have the number 4 minus 1 and 1/3. So if I want to show you on a number line. And on a number line, we're trying to go from 1 and 1/3 to 4. Remember, on a number line, the numbers that are smaller are to the left and are larger to the right. So that's why we have 1 and 1/3 on the left and 4 on the right-hand side. Now we have to think, I want to get 1/3 to the nearest whole. So if I have 1/3, how many more thirds would I need to have the next whole? I would need 2/3 more, because 2/3 plus 1/3 is 3/3, and 3/3 is 1 whole. So if I had 1 already, so this 1 in front, plus another whole, that would put me at the number 2. Now how do I go from 2 to 4? Well, I have to add 2 wholes. So if I did 2 plus 2/3, that means that my answer is 2 and 2/3. Just by jumping and counting up. This is a strategy that works only when the first number is a whole number and it is subtraction. 6, if you are ever confused, always turn your mixed numbers into improper fractions first. That is a fail-safe way of always doing it. If you turn everything into improper fractions first, it's going to be much easier. There's only one issue with improper fractions. You generally end up with larger numbers. So that's the only downside to improper fractions, is that a lot of your numbers will end up being larger. Why do we do this? Fractions and mixed numbers show up in all sorts of places. Measurements, recipes, medicines, or when we need a very specific amount of something. We must know how to add or subtract these amounts together. So we've come to our sample questions, and there will be quite a few because I want to show every different type of example that we'll come across. So you can either do them with me, on your own, or anything in between. So let's look at our first sample question. We have 3/4 plus 2/3. Now, I'm first going to look at my denominators. They're not the same. So I'm going to take this to the side, and I'm going to find the least common multiple of 4 and 3. So I'm going to count by 4s. 4, 8, 12, 16, 20. 3, 6, 9, 12, 15. And I see that my LCM is 12. What that means is that both of my fractions are now going to be out of 12. So I have 3/4 will now have a denominator of 12, and 2/3 will now have a denominator of 12. 4 times 3 gave me 12, so 3 times 3 gives me 9. 3 times 4 gives me 12, so 2 times 4 gives me 8. Now I can add my numbers together. I have 9/12 plus 8/12 is going to give me where did I get 20 from? 17/12. Now that I have 17/12, I know that this is an improper fraction, so I'm going to turn this back into a mixed number. So I'm going to take 17 divided by 12 is 1. 1 times 12 is 12. Subtract, we get 5. We get 1 and 5/12. So I know some of you may say, why did we have to turn it back into a mixed number? Oftentimes when you do present a number, we rarely present something as an improper fraction. But like I've said, please just check your answer choices. If it's fill in the blank, it'll also tell you what method to choose it or to put it into. But in this case, it is just a good habit to put things as a final answer into mixed numbers. Simple question 2, we have 1 1/2 plus 7/8. So in this case, I'm going to show you the fail-safe method of turning everything into an improper fraction first. So we have our mixed number. So I'm going to take 2 times 1 is 2, plus 1 is 3. So this really becomes 3/2 plus 7/8. If you were confused about how to convert between mixed and improper, please make sure you go back to check out that video. We're going to look at for our LCM because our denominators are different. So we're going to look for the LCM of 2 and our LCM of 8. Some of you may already be yelling it. You might already know. So we have 2, 4, 6, 8, 10, and our first multiple is 8. That should be a really good indicator that your LCM is just going to be 8. I like to check if one of my denominators goes into the other one. 2 goes into 8, so that would have been an easy way to notice that 8 was going to be your LCM. So that means that we have 3/2 is going to have a denominator of 8, and 7/8 is going to have a denominator of 8. 7/8 already has a denominator of 8, so that's fine. 2 times 4 is 8, so I do 3 times 4 gives us 12. So now I have my two fractions to add. I have 12/8 plus 7/8 is going to give me 19/8. And I'm going to turn this then into a mixed number. So 19 divided by 8 goes in 2 whole times. 2 times 8 is 16. Subtract, we get 3. So our final answer would be 2 and 3/8. Sample question number 3. We have 3 4/5 plus 4 1/4. So I'm going to show you the method where we can add whole numbers together. So step 1, I'm going to do 3 plus 4 equals 7. And I'm going to hold on to that. Second, I'm then going to take my fractions. 4/5 plus 1/4. I do have different denominators. So I have 5 and I have 4. So I'm going to find the LCM of 4 and 5. One good hint. If your denominators are only 1 away from each other on the number line, so 4 and 5 are next to each other, the LCM is always going to be your number multiplied together. But I can show you that. That's 4, 8, 12, 16, 20, 5, 10, 15, boom, 20, you got it. That is our LCM. So now I'm going to turn each of my fractions, 4/5 and 1/4, into fractions that have a denominator of 20. 5 times 4 is 20. 4 times 4 is 16. 4 times 5 is 20. 1 times 5 is 5. Now I can add these together. So I'm going to get 16 twentieths plus 5 twentieths is equal to 21 twentieths. But wait, we have an improper fraction here. So I'm going to do 21 twentieths. Divide is 1, 20, with 1 left over. So it equals 1 and 1 twentieth. Now some of you may say, my final answer is 1 and 1 twentieth. But it's not. We have to add the 7 from the beginning. So 7 plus 1 and 1 twentieth is just going to be 8 and 1 twentieth. Final answer. And we avoided having to use really large numbers. So that's why we can use this for just addition. Sample question number 4, we have 8 plus 3 and 5/6. The great part about these, 8 does not have a fraction. So we can just add 8 plus 3 is equal to 11. And then tack on your 5/6. So your answer is just going to be 11 and 5/6. Super easy when one of these numbers is a whole number. All right, sample question number 5. We're just about halfway through. So subtraction is the exact same. So if we look, we can see that we have two different denominators. So we're going to find our LCM. So when we look for the LCM of 10 and 3, some of you may already know where these two are going to cross. You know that if you count by threes, you have to hit one that ends in a 0, since all of multiples of 10 end in a 0. So if you do need to see it, 3, 6, 9, 12, 15, 18, oh my gosh, I forgot 9, 18, 21, 24, 27, 30. So our LCM in this case is 30. So that means our new fractions are out of 30. So we get 9 tenths and 1/3, both out of 30. We have 10 times 3 is 30. So 9 times 3 is 27. 3 times 10 is 30. So 1 times 10 is 10. So our new problem is 27 tenths. Oh my gosh, not tenths. 27 thirtieths minus 10 thirtieths is equal to 17 thirtieths. We can do a quick check to see if we can simplify this. This is something that generally we do as well. We haven't had to simplify yet. 17 is a prime number. It does not have any factors that would go into 30, since 17 itself does not go into 30. All right, so let's look at sample question number 6. We have 5 1/4 minus 5/8. I'm going to show you one method here before we decide if we have to subtract anything, before we subtract. So what I like to do is, if we take this and we actually take our 5 1/4 minus 5/8, and we focus on just the fractions first. So let's look at the LCM of 4 and 8. Now, if you think about the multiples of 4 and 8, where would your LCM be? Well, notice the first multiple of 8 is 8, and 4 goes into 8. So our LCM is just going to be 8. So let's take 1/4 and make it out of eighths. We can also take 5/8 and make it out of eighths. 5/8 already is out of eighths. Nothing to do. 4 times 2 is 8. 1 times 2 is 2. So we get 2/8. In this case now, we have 5 and 2/8 minus 5/8. From here, we know that we have to borrow. We cannot do 2/8 minus 5/8. 2/8 is smaller than 5/8, so we cannot just subtract them. So we can do two things, and I'm going to show you a method that may make more sense to you. If we turn 5 2/8 into an improper fraction, So we multiply. 8 times 5 is 40. Plus 2 is 42. I now have 42 eighths minus 5 eighths. I can do that. That's going to give me 37 eighths. Now I can just convert it back. 37 divided by 8. That's 4. 8 times 4 is 32. 37 minus 32 is 5. So my final answer is 4 and 5 eighths. If you have to borrow, turn things into improper fractions so there is no borrowing needed. The borrowing part, if you understand it, is wonderful. If not, totally fine. And I will show you how to borrow on this one. So we have 8 and 7 eighths minus 2 and a half. If we have to borrow, this is why we double check, even triple check. What I notice is first I have two different denominators. So I'm going to then find my LCM of 2 and 8. Remember, ask yourself that question. Does one of these numbers go into the other? 2 goes into 8. So our LCM is just going to be 8. So I'm going to bring this number down, 8 and 7 eighths. 7 eighths is already out of eighths. If I take 1/2 and I make it out of eighths, times 4 times 4, we get 4 eighths. So I now get minus 2 and 4 eighths. Why we do equivalent fractions first is to see if you have to borrow. Can I do 7 eighths minus 4 eighths? Yes, that equals 7 minus 4 is 3 eighths. The larger number came first. 8 minus 2 is 6. We get 6 and 3 eighths. Final answer. See how much we saved time by finding equivalent fractions first before we made it an improper fraction. That is totally fine to do. It will also keep you from dealing with a lot of larger numbers in the beginning, because if 7 eighths was actually smaller than what was there behind it, we could have just then turned it into an improper fraction and subtracted from there. Number 8, we have 4 and 1/5 minus 2 and 2/3. Let's do the same thing. Let's find the LCM of 5 and 3. So count by threes, 3, 6, 9, 12, 15, 5, 10, 15. You should have clocked that you've said the same number now, only once. So the LCM is 15. All right. So let's make our equivalent fractions. So I'm going to turn 1/5 is out of 15ths, and I'm going to take 2/3 and make it out of 15ths. Times 3 equals 3/15. Times 5 equals 10/15. I've showed you, I might have put finding the equivalent fractions in all different places, but notice the method's the exact same. Sometimes it's all about just determining the amount of space that you need. So right now we have 4 and 3/15 minus 2 and 10/15. I cannot do 3/15 minus 10/15. But here's what we're going to do. I'm going to show you how to borrow. If this does not make sense for you, turn them into improper fractions from here and subtract. Very similar to what we did 2 problems ago. So, from here, just like in subtraction, we'd have to borrow from one of our wholes. So we would no longer have 4 wholes, we would have 3. So what do we add? If one whole has how many pieces? One whole has 15 pieces, because that's the denominator right here. And if we had all of them, we would have had 15 out of 15 pieces. That one whole that we borrowed is 15/15. So now we have 3 and 18/15. We want the improper fraction here, minus 2 and 10/15. 18/15 minus 10/15 is 8/15. 3 minus 2 is 1. So my answer is 1 and 8/15. A little crazy. If the borrowing didn't make sense, again, I just want to show you different methods. It is up to you to choose which method that you like. Final sample question number 9. I know we have made it. We have 6 minus 1 and 1/6. I'm going to show you again 2 different methods to do this. So let's look at, some of you may say, what am I going to start with? 6 doesn't have a denominator. Any whole number has a denominator of 1. So I can change this to 6/1 minus, and we're going to turn this into an improper fraction. 6 times 1 is 6, plus 1 is 7. So we do it by 7/6. Whenever you have a denominator of 1 and the other one is 6, your LCM is just going to be whatever the other number is, which is in this case 6. So I'm going to take 6/1 and make it out of 6. So 1 times 6 is 6, so 6 times 6 is 36. So what I really have here is 36/6 minus 7/6 is equal to 29/6. I can then divide 29 divided by 6. That goes in 4 times. 6 times 4 is 24. Subtract, we get 5. And my final answer would be 4 and 5/6. What I want to show you real quick, we could have also counted up because our first number in the beginning was a whole. So that's 6, and we have 1 and 1/6. Our first jump is to bring up whatever fraction we have to one whole. I would have needed 5 more sixths to be added to 1/6 to get me to the number 2. How do I get from 2 to 6? That's a jump of 4. Put the two of them together, 4 and 5/6. All right, everybody, we have come to the end of adding and subtracting fractions and mixed numbers. I hope this was helpful. It is now your turn to go forth, try these out, and I can't wait to work with you soon. Good luck. Y'all, that was wild, but congratulations on crushing another lesson here at Nurse Hub. You should be proud and then continue working to make sure you fully understand everything that you just watched. Remember, practice is the only thing that we need to make ourselves better at all of these topics. Good luck, and I hope to see you soon.